let's do chapter 16, problem 3. So we are on page 442 and doing problem 3. So let's do a reading of the problem. And on the average, a hydrogen atom emits a 21 centimeter photon every 15 million years. What is useful about a photon emitted at a wavelength of 21 centimeters is that it can be detected by our radio telescopes. So this wavelength is in the radio. So the question is, how many of these 21 centimeter photons does a 100 solar mass gas cloud emit per second? So we have a gas cloud, and the first thing is, what is the mass of the gas cloud? Well, the mass of the sun is 2 times 10 to the 30th kilogram, and this is given as 100 solar masses, so that's equal to 2 times 10 to the 32 kilograms. So that's the amount of kilograms that's in our gas cloud. The next question is, how many hydrogen atoms are in the gas clouds? Well, if we take the mass of the gas cloud, 2 times 10 to the 32, and divide it by the mass of a hydrogen atom, which is given to us on page 313 as being 1.7 times 10 to the minus 27. This is the mass of one hydrogen atom. This is the mass that's available. So if we divide the mass of one hydrogen atom into the mass that's available, we get the number of hydrogen atoms. These will roughly cancel out. And when you have a 32 on the top and a minus 27 on the bottom, then it's a 10 to the 59 atoms. So 10 to the 59 atoms will emit in 15 million years. So how many seconds is that? So it's 15 times 10 to the 6 years, and 1 year is 3.2 times 10 to the 7th seconds. So 3.2 times 15, these two numbers multiplied together, is right around 50. And 10 to the 6th times 10 to the 7th is 10 to the 13th. So if 10 to the 59 atoms are going to emit in 10 to the 13th seconds, then how many of them are going to emit in 1 second is a matter of 10 to the 59th over 50 times 10 to the 13th. So 10 to the 59th is 100 times 10 to the 57th over 50 times 10 to the 13th. And 50 goes into 100 about 2 times, and 10 to the 57th divided by 10 to the 13th is 10 to the 44. So we have 2 times 10 to the 44 of these hydrogen atoms emitting in 1 second, a very large number.